Before James Webb soared into the sky, the essence of the process that shaped galaxies was likened to a path seeking order in the chaos of the primordial universe. The universe at the moment 13.7 billion years ago was a boiling pressure cooker with matter exploding exponentially to hundreds of powers. Scientists call it the Planck era, with the burst of matter-energy explosion, inflation. Shortly after, everything began to cool down. The process of matter reionization began with the formation of the first stars, shining brightly like nuclear reaction furnaces before collapsing, becoming star nurseries for future generations and also the predecessors of ancient galaxies. Before 2021, no one questioned this hypothesis. It was regarded as an obvious truth and spread as common knowledge. However, James Webb is changing everything. People hope that this time machine can provide more evidence for theories that have been deployed, but no one could have expected it to be powerful enough to change the very foundation of basic knowledge. What is happening? Does the universe have the shape and form as we once depicted? Everything will gradually crumble. However, don't worry, because we will always keep an open mind to new theories. Welcome back to our journey exploring the story of galaxies in today's video. Together, we will objectively look at the strange galaxies that James Webb has recently discovered. They're bigger than we imagined. This is exactly the astronomers' thoughts as they first directed the time mirror on James Webb into the past. Alongside the excitement over the unprecedented success of the Hubble successor, scientists also had to rack their brains explaining to the public the strange galaxies they inadvertently stumbled upon. A myriad of questions and hypotheses from the media, coupled with the immediate truth, was enough to give the entire astronomical community a headache, causing many researchers to consider shutting down and withholding information. After all, they weren't ready to reconsider the fundamental theories painstakingly built over generations. But sadly, the truth remains. It won't pass judgment, whether you're willing to accept it or not. The first blow came 3 years ago with the discovery of a seed of life, born 12 billion years ago. Under the watchful eye of the James Webb Space Telescope, the time-traveling image of a universe's dawn revealed the oldest seed of life ever recorded. It is embodied in the entity designated SPT041847, a galaxy obscured by dust, existing since the universe was only about 10% of its current age. According to Sci News, a research team led by Professor Joaquin Vieira from the University of Illinois at Urbana-Champaign, USA, has analyzed data from James Webb and discovered the presence of polycyclic aromatic hydrocarbons, PAHs, within the dust particles of a glowing galaxy captured by the SPT041847's infrared wavelength images. Located relatively far away, over 12 billion light-years from Earth, the signs of life in this galaxy are represented by the oldest PAH data ever found by humans. The spectroscopic data from the galaxy reveals that the interstellar gas within it is enriched with heavy elements. This implies that the galaxy has undergone a long and active process, with multiple generations of stars being born and dying. The developmental principle of the universe, originally composed of a few meager elements, is the increasing creation of more elements through the reactor in the cores of stars. When a star completes its life cycle and explodes, it adds new elements, enriching the chemical composition of the universe. This suggests that the formation of stars and ancient galaxies may have occurred much earlier than anticipated by humanity. According to the Big Bang theory, the first 2 billion years mark the period of maximum turbulence in the universe. Gases continuously merge to form giant stars, which then explode, while dark matter silently gathers to bind superdust clouds together, creating nurseries for the first galaxies. At this time, very few large galaxies are formed. Small galaxies, on the other hand, differ slightly. They continuously form and then dissipate, due to unstable core stars exploding and dispersing material rather than gathering to form star nurseries. Billions of galaxies have appeared and vanished in this manner. For many years, based on limited observations, we believed that the emergence of supermassive galaxies with stable structures similar to the Milky Way was improbable. However, that belief is slowly being shattered by evidence from James Webb. More brutally, the existence of SPT 041847 is not unique. According to a study published in the journal Nature, James Webb's NIRCam instrument, capable of operating in the near-infrared spectrum invisible to the naked eye, has detected 6 galaxies in a region of the sky with limited previous exploration. Previously, the Hubble Space Telescope had traced the traces of 2 of these 6 galaxies, but the images obtained at that time were too blurry, and these traces went unnoticed. Scientists still need to perform additional measurements to confirm the existence of these 6 galaxies, but they believe that these galaxies contain more stars than expected, with one galaxy thought to harbor around 100 billion stars. Ivo Labbé, the study's author from Swinburne University of Technology, Australia, emphasizes that with such a quantity, this galaxy could be the size of the Milky Way, which houses our solar system. The idea that the Milky Way took a time roughly equivalent to the universe's formation, time to gather stars, comes from Mr. Labbé. However, the younger galaxies only took about 700 million years to achieve a similar level of development. This implies that the rate of formation for these galaxies is 20 times faster than the Milky Way's. The early appearance of galaxies right after the Big Bang contradicts the current model of the universe known to humanity. According to the theory, galaxies slowly develop from very small initial points, sizes smaller by about 10-100 times than the current observed sizes. However, the actual sizes of these galaxies are too large, presenting an inconsistency in the current theory. Scientists believe that dark matter might have played a role and led to these results. Although our understanding of dark matter is limited, it is considered a key player in the galaxy formation process. Labbé explains that when dark matter clumps into a glowing halo, it attracts gas from the surrounding universe, forming a galaxy and stars. However, this process is thought to take a long time, and in the early universe there weren't many clumps of dark matter like that. Astronomical physicist David Elbaz at the French Atomic Energy Commission suggests that the newly discovered galaxies may indicate that everything in the early universe developed much faster than previously estimated, allowing stars to form more efficiently. This could be related to recent signs suggesting that the universe itself is expanding faster than we once thought. The twin sister, Sears 2112. Why are the formations of galaxies oddly intriguing to the field of physics? Well, in astrophysics, studying the structure of galaxies at different distances, meaning at different times in the evolution of the universe, is essential to help us understand the history of the formation and evolution of the Milky Way. In the nearby universe, over half of the massive spiral galaxies have elongated structures in the form of a bar in their central regions, similar to our own galaxy. These bars play a crucial role in the evolution of a galaxy, as they facilitate the mixing of elements that are characteristic of star formation. However, according to the predictions of many theoretical models, the physical conditions and dynamics in the early universe do not support the formation of bars in galaxies that formed early and therefore are at the farthest distances. Therefore, it is believed that the structure of spiral galaxies like the Milky Way was not reinforced until the universe reached about half of its age, measured to be 13.8 billion years. Now, a leading team from the Center for Astrobiology, CSICINTA, has discovered a galaxy in the early universe with a barred spiral structure similar to the Milky Way. Observations conducted by JWST reveal a barred spiral galaxy confined in the universe at just 2.1 billion years old, challenging previous ideas about galaxy formation. The story begins with a summer vacation in the Cantabria region of Spain last year for astrophysicist Luca Constantin. Late on the evening of August 1st, after exploring the beaches and green mountains of San Vicente de la Barquera, Luca returned home and checked his email as usual. High-resolution images from James Webb had been sitting in the inbox for a while. As a habit, he began to view and classify celestial bodies within them, and, unexpectedly, he stumbled upon something. Luca discovered the galaxy Sears 2112, a twin sister to the Milky Way, Earth's home, on the other side of space. His initial reaction was one of astonishment. Since James Webb officially became operational, fresh discoveries have been flowing in like a tidal wave, leaving scientists perplexed. Yet they cannot deny the truth. Finally, Sears 2112 was named after the early release science program for the evolution of the universe, involving astrophysicists from the Center for Astrobiology. After the research process, Constantin and his colleagues revealed that galaxies similar to the Milky Way existed 11.7 billion years ago, when the universe was only 15% of its current age. The 33-year-old Italian researcher stated, "It's like seeing our galaxy turning back time." Astrophysicist Pablo G. Perez Gonzalez compared this discovery to a 100-year-old person who has never seen themselves in the mirror, receiving a letter with a self-portrait that an unknown twin sent when they were 15. This is the farthest known galaxy resembling the Milky Way in scientific knowledge. The galaxy Sears 2112 is located in the region of the sky between the constellations Ursa Major and Boyero, marked by a dotted line resembling a human figure that contains the star Arthur, one of the brightest in the sky. The stars in Sears 2112 have a combined mass of about 3.9 billion solar masses, which is similar to the estimated mass of the Milky Way during that time, according to lead authors of the study, Perez Gonzalez and Constantin, from the Astrobiology Center in the Madrid town of Torrejón de Ardoz. Perez Gonzalez explains that at that time, the Milky Way had a mass of approximately 10 times less than what the stars in Sears 2112 currently have. The Milky Way features a long bar-like structure in its central region. The Hubble Space Telescope has aided researchers in studying about 2,000 galaxies with similar structures about 15 years ago. NASA astronomers then concluded that the central bars are the final stage in the evolution of spiral galaxies, as they form when the orbits of stars become unstable and deviate from their previous circular paths. Within these bars, a significant amount of gas accumulates, giving rise to new stars and transforming the galaxies. The galaxy Sears 2112 is a young galaxy that emitted light that reached the telescope. Surprisingly, it has a bar in its center, which is tremendously important for the formation of life. Pablo G. Perez Gonzalez, a researcher, explains that the elliptical orbits of previous stars transported materials from where more stars form in a galaxy to the outer zones. This process was necessary for the sun to form with its metals and for a planet to form around it, with a lot of iron, nickel, carbon, silicon, and all the ingredients of life. The Milky Way can have an infinite number of twins, and by observing each one at a different age of the universe, researchers hope to understand the history of the evolution of the Milky Way. Discoveries like Sears 2112 could serve as a foundation for future research on the nature of massive galaxies, potentially opening new doors for studying the origin and early development of galaxies. What if the formation of galaxies did not involve dark matter? In recent years, with the emergence of numerous unprecedented pieces of evidence, the field of dark matter has begun to be scrutinized by scientists. Contemporary astrophysicists assume that matter was not uniformly distributed in the universe after the Big Bang. Denser regions attract more matter due to their gravitational forces compared to the surrounding areas. Over the course of billions of years, the eventual condensation of these last gas clouds led to the formation of the galaxies we observe today. An essential component of this theory is dark matter. On one hand, it is considered the cause of the initial imbalance in distribution, leading to the condensation of gas clouds. It also explains some perplexing observations for astrophysicists. For instance, stars within galaxies often rotate so rapidly that they should eventually be ejected. There is an additional gravitational force within these galaxies that could prevent this from happening, a kind of stellar glue that telescopes cannot observe. Dark matter. Nevertheless, it doesn't directly tie back to its own existence. Perhaps these gravitational forces simply behave differently than we previously thought, suggests Professor Pavel Krupa from the Helmholtz Institute for Radiation and Nuclear Physics at the University of Bonn and the Institute of Astrophysics at Charles University in Prague. This hypothesis, known as MOND, modified Newtonian dynamics, was discovered by Israeli physicist Mordechai Milgram. According to this theory, the gravitational interaction between two masses follows Newton's laws only up to a certain point. Under extremely slow accelerations, as in the case of galaxies, it becomes significantly stronger. This explains why galaxies do not break apart as a result of their rotation speeds. Within the framework of collaboration with Dr. Benoit Fameye in Strasbourg, research students guided by Krupa simulated for the first time to see whether galaxies could form in a Mondi universe and, if so, what they would produce. To do this, they used a computer program to calculate complex gravitational forces developed by Krupa's team. Because, with MOND, the gravitational pull of an object depends not only on its mass, but also on whether other objects are in the vicinity. The scientists then utilized this software to simulate the formation of galaxies and stars, starting from a gas cloud hundreds of thousands of years after the Big Bang. In many aspects, their results closely approximated what scientists observe in reality with astronomical telescopes. In the experiment, the distribution and velocity of stars and galaxies created by the computer followed the same pattern as one can observe in the night sky. Moreover, the simulations predominantly resulted in the formation of galaxies with disk-like rotations similar to the Milky Way and most of the large galaxies we know. On the other hand, simulations of dark matter primarily led to galaxies without distinct disk-like structures, an inconsistency with observations that is challenging to explain. Calculations based on the existence of dark matter are highly sensitive to changes in certain parameters, such as the frequency of supermassive stars and their impact on the distribution of matter in galaxies. In MOND simulations, these factors play less definitive roles. In the newly published results from Bonn, Prague, and Strasbourg, the simulations do not correspond well with reality in many aspects. The new simulations are just a first step. Scientists not only made very simple assumptions about the initial distribution of matter and conditions in young cosmic structures, but plan to incorporate more data for the computer to verify these hypotheses in the future. Indeed, dark matter and dark energy remain enigmatic components without definitive confirmation. The majority assert that they truly exist and play the role of invisible agents in our universe. On the other hand, some argue that they might merely serve as placeholders for gaps in scientific understanding. The ultimate answers are still awaiting discovery in the future. The truth is that there will always be aspects of existence that surpass human imagination, exemplified by galaxies devoid of dark matter. Strange giant monsters. Astronomers believe that galaxies cannot form without the gravitational push of dark matter. Therefore, the existence of galaxies devoid of this mysterious substance, without a clear cause, could be a remarkable discovery. In a paper published in Nature, astronomers claim to have observed a system consisting of 11 galaxies lacking dark matter, possibly formed in the same ancient collision. However, many of their colleagues consider this statement to be a hypothesis. This type of system could be used to study how galaxies form and the nature of dark matter. If proven correct, this is certainly fascinating regarding the formation of galaxies. However, no one has definitively confirmed this yet, says Shervin Laporte, an astronomer at the University of Barcelona in Spain. The discovery of the peculiar nature of two galaxies, DF2 and DF4, was made by Peter van Dokkum at Yale University in New Haven, Connecticut in 2018 and 2019. The stars in these two galaxies exhibited slow motion to an extent that did not require the gravitational push of dark matter to explain their orbits. As a result, the research team concluded that these galaxies lack dark matter. However, their discovery stirred controversy because DF2 and DF4, seemingly stable, differed from other known dark matter-free galaxies, which are young and short-lived, formed in the arms of larger galaxies containing dark matter and separated by a neighboring galaxy. How both DF2 and DF4 were formed remains a mystery. In their latest paper in Nature, van Dokkum's research team not only links these two unusual galaxies, but also suggests that their characteristics are intimately tied to their formation through a high-speed collision that occurred 8 billion years ago, creating various structures. Van Dokkum's research team has presented scenarios from simulations to explain the unique features arising from large-scale collisions between galaxy clusters. The researchers propose that when two ancient galaxies collide, their dark matter and stars may have been transferred away. Dark matter might not interact, and stars could be too far apart to collide. However, when dark matter and stars accelerate, the gas in the space between the stars and the two galaxies may collide, compress, and move slowly, leading to a streak of matter that later forms new galaxies without dark matter. Subsequently, the research team searched for more galaxies in the streak of matter between DF2 and DF4. They identified about 3 to 7 new candidates for dark matter-free galaxies, including some faint galaxies in the tail, which could have dark matter and remaining stars from the two ancient galaxies. It's like looking into the face of it to see what we're looking for. If this picture is proven to be correct, it might help astronomers understand how dark matter behaves and provide insights into the conditions under which galaxies can form. The collision of the Milky Way might serve as a new laboratory to explore whether dark matter interacts with itself, according to Guo Ogia, an astronomer at Zhejiang University in Hangzhou, China. Astronomers need to measure the mass of the ghostly galaxies at the end of this streak, the potential dark matter galaxies, to test whether they contain as much dark matter as the models predict. Our journey to understand the universe becomes increasingly miraculous with the images brought by the James Webb telescope during the cosmic dawn. The peculiar galaxies, shining like newborn stars, have captured the attention of astronomers. This opens up new opportunities to explore the origin of the universe and the formation and evolution of these large but mysterious structures. The James Webb telescope is not just an observational tool, it's a gateway to a new perspective for humanity. These discoveries belong not only to scientists, but also to us, those witnessing a small part of boundless understanding. Let's eagerly await the next images and data from the James Webb telescope. Meanwhile, let these wondrous galaxies enchant our hearts and souls, reminding us of the incredible power of exploration and curiosity about the mysteries of the vast universe.